Hey, very good morning, students. Let us look into our next topic called counters. Today, in this session, let us understand what is a counter. Then we will see what are the different types of counter, classification of counter, and applications of counter. Let me start with the definition. The basic definition of a counter is nothing but it is used to count number of clock pulses. That is the first preliminary basic definition. So what is a counter? Counter is used for counting clock pulses. Okay, counter is used for counting what? Clock pulses. It is also used as a frequency divider. In the next coming slides, we will say how it is used as a frequency divider. But now you need to remember that it is used to count what? Clock pulses. There are two types of counter. One is up counter, other one is down counter. What is up counter? Up counter is it is used to count the clock pulse in forward fashion, that is 0, 1, 2 till n. What is down counter? Down counter is used to count the clock pulses in reverse fashion, backward fashion, n minus 1 till it reaches 0. Clear? So there are two types of counter, up counter and down counter. Up counter counts from 0 to n, down counter counts from n to 0. So there are two types of classifications of counter. One is synchronous, other one is asynchronous. Let us see this one. It's a very important question, a 2-mark question, difference between synchronous counter and asynchronous counter. So let us understand this through a diagram. So synchronous counter means what? The memory elements are having same clock pulse. What is a memory element? Memory element can be any flip-flop, JK, T, D or RS. So if all the memory elements, if the memory elements are connected to the common clock, okay, I just want to show you an example. I've taken a circuit for the understanding. Okay, memory elements, here I've used JK memory element, JK flip-flop. Here both the flip-flops are connected to a common clock. Can you see the common clock is connected to both the flip-flops? That is why we say memory elements are having same clock pulse. I call that type of circuit as what? Synchronous counter. Now what is asynchronous counter? Here memory elements are having different clock. Let us see how. Here can you see the circuit? It has three flip-flops, T, first one, second one and third one. Here the first flip-flop is connected to the main clock, whereas the second flip-flop, output of first flip-flop is connected as a clock of second. Output of second flip-flop is connected as a clock of third. It means the main clock is only applied to the first flip-flop. Main clock is only applied to the first flip-flop. Then for all the rest of the flip-flops, the output of previous flip-flop is connected as a clock. The output of previous flip-flop is connected as a clock. This is the different classification of what? Synchronous and asynchronous. A very common classification is common clock to all the flip-flops, or you can say memory elements are having same clock. Memory elements are having same clock. In asynchronous, memory elements are having different clocks. Okay, you call it as asynchronous. Okay, next let us see in detail. So if I want to design a 3-bit counter, what is 3-bit counter? Maximum it can count 2 per n. For example, let us consider a n-bit counter. N-bit counter means it can maximum count 2 per n clock pulses. If it is a 3-bit counter, 2 to the power of 3, it means totally it can count only 8 clock pulses. If it counts from 0 to 7, I call it as up counter. If it counts from 7 to 0, I call it as down counter. Let us see in detail. Okay, let me take a 3-bit counter. If I say 3-bit counter, it means 2 per 3 is 8. So it is 0, 0, 0, 0, 0, 1, 0, 1, 0 till 1, 1, 1. Maximum 8 combinations, 8 possibilities, right? So this 3-bit counter can count how many pulses? 8 clock pulses from 000 to 111. Let me draw the signal graph for you for your understanding. What is signal graph, ma'am? So this is my clock. You know, clock is nothing but series of positives and negative pulses are called as clock. Now I have 3 bits, so it is 3-bit counter, Q0, Q1, Q2, Q0, Q1, Q2. What is Q0? 0, 1, 0, 1, 0, 1, 0, 1. So I have written 0, 1, 0, 1, 0, 1, 0, 1. What is Q1? 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Done. What is Q3? Q2? 4 zeros, 4 ones. 4 zeros, 4 ones. Now just plot it. How will we plot it? You know 0 means low. 1 is high. Low, high, low, high, low, high. Done. Similarly plot for Q1. Double low, double high, double low, double high. Done. Now 4 zeros. 4 lows, 4 ones, 4 high. Done. Now what is that we need to see is, what is a time period T? T means a positive and a negative clock will form a T. You understand? A positive and a negative will form a time period. Now in this Q0, a positive and a negative has 0 and 1, 2 bits. Can you see? A positive and a negative has how many bits? 2 bits. So the frequency is divided by 2. Now here in Q1, a positive and a negative has how many bits? 1, 2, 3, 4. So the time period is distributed as how many bits? 1, 2, 3, 4. So frequency is divided by 4. Here a positive and a negative has how many bits? 1, 2, 3, 4, 5, 6, 7, 8. So frequency by 8. That is why we call counter as what? It is also used to divide the frequency. We call it as what? It is also, we can use it as a frequency divider. So that is also one application of counter. Counter is used as a frequency divider. So these are the various applications of counter, definition of counter, types and classification. So with this, I wind up this video. So we have seen what is a counter. Counter is used for counting clock pulses. 2 types of counter, up counter, down counter. 2 classifications, synchronous and asynchronous. Thank you.